Hey everybody, we are to our last video in business calculus, and it is about optimization. And that really is what business is all about, is optimizing things. Again, minimizing cost, maximizing profit, making sure that you're successful at whatever business endeavor you choose to go for. Applying that to mathematics, we have already talked about partial derivatives, even multiple partial derivatives, which we're going to need. One of the key things that's going to be coming up is this d once again. And if d is positive, then we say one thing. If d is negative, then we say something else, and so on. We're going to push on from there. Our first example that we have here is we need to find f sub xx and f sub xy. So let's start here. F sub xx. We'll start with f sub x. Is the first derivative with respect to x only, meaning y in this case is a constant relative to the variable x. This is going to give us negative 8x to the third minus 4y to the sixth. And the 4y to the third is 0 because it's a constant relative to what we're doing. And if I take the second derivative of that with respect to x, that minus 4y to the sixth goes to 0. And I end up with negative 24x to the second power. And so there is my first answer. And then it also asks for x sub xy. So I'm going to take that first one there. So f sub x, that's the negative 8x cubed minus 4x to the sixth, y to the sixth. And I'm now going to take the derivative of that with respect to y. And that's going to, the negative x to the third goes to 0. It's a constant relative to y. And now this is going to give me a negative 24 y to the fifth. And there is our second derivatives answers as we're looking at them. All right. And we have a second one here. And they want us to find the critical point of this function here. I'm going to squeeze it in here. The ones after this, I'm going to go to a blank sheet of paper because it gets quite extensive, especially the next one that we're going to do. By the way, I am not going to be doing this one. The next one I'll be doing after this is here, and that one is the longest of the bunch. And I'm going to try to fit this here. So this is f sub x is going to be 3 plus 8x plus, actually that's it. So there's my my derivative, and then f sub y, meaning the derivative with respect to y, is going to be 0, 0, 0, negative 5 minus 14y. And what we're going to do with this is we're going to set each of these equal to 0 and solve each one. So this implies that x is going to be negative 3/8 and y is going to be a negative 5 over 14. And that is our critical point. That is it. And we're going to decide if the critical point is a saddle point or whatever. I'm going to note that f sub xx, by the way, just to be clear, this is our solution here. But we are going to decide if it is a saddle point, a minimum, or a maximum. And the derivative with respect to x, so I'm back at f sub x on the left there, and the 3 goes away, and I'm just left with the 8. F sub yy is going to be negative 14. And f sub xy, so if I take the derivative of f sub x, that's 3 plus 8x. With respect to y, that goes to 0. So d in this case becomes 8 times negative 14 minus 0 squared. And that gives me a negative, so let's see, 8 times 14, so negative 112, which is obviously less than 0. So the point -3/8 and -5/14 for the y is a saddle point. Meaning it is not a minimum or a maximum. It's a saddle point, which means we kind of get a zero derivative there, but then it doesn't max out or min out or anything like that. All right, and for this next one here, I'm actually going to copy this onto a blank sheet. And this is going to give me, so let's start with the function. So f sub xy, or they're calling it z, which is, I'm going to call it x. Come on, there we go. So z, which is f of xy, is x squared minus 4x and y squared minus 3y. And it's very nice that they separated out the function of x and the function of y separately like that. That's going to make it a lot easier. So we're going to start with taking the derivative with respect to x. That's going to be 2x minus 4 times y squared minus 3y. Remember, y squared minus 3y is just a constant times the function of x relative to x. Z sub y is going to be x squared minus 4x. And the derivative with respect to y is going to give us a 2y minus 3. And we are now going to solve this system of equations, because we're now going to set these equal to 0. And before I solve that system, I want to go off to the side here and note that z sub xx is 2 times y squared minus 3y. Z sub yy is 2 times x squared minus 4x. And z sub xy is 2x minus 4 and 2y minus 3. So we'll keep those in mind. We're going to come back to those. But for now, I want to solve this system of equations here. And I'm going to note that for the z sub x, I'm going to get 2x minus 4 equals 0. Y squared minus 3y also equals 0. So let me color code this a little bit. So I'm going to deal with this first function here. So we're here. So x is 2. Y, I factor a y out, and I get y equals 0 and 3. And we are going to explore all three of those possibilities. So let's start with at x equals 2. Well, I'm now going to go back into the other one. So this is all from the first equation. I'm going to put everything into here. So when x equals 2, I get 2 squared minus 4 times 2. And then 2, was it y squared minus 3y equals 0. I'm sorry, I'm plugging this into the wrong one. I need to plug this into the other equation. Yeah. So this is going to be 2 squared minus 4 times 2, and then 2y minus 3. And this is going to give me 4 minus 8, that's -4, and then 2y minus 3. And that, of course, is going to equal 0. So y is going to be 3/2. So my first critical value is 2 3/2. Next up, at y equals 0, And I'm going to plug that into the second one. So this is going to be x squared minus 4x, and 2 times 0 minus 3. That's going to give me negative 3. X squared minus 4x equals 0, which means x equals 0 and 4. So here are two more critical values. And at y equals 3, again, I'm plugging that into the purple there. That's going to give me 2x minus 4, oops, x squared minus 4x, and then 2 times 3 minus 3. 2 times 3, 6, 6 minus 3 is 3, so this gives me 3 x squared minus 4 minus 4x equals 0, which means x equals, once again, 0 and 4. So that gives us some more points. It gives us 0, 3, and 4, 3. So that's a total of 5 possibilities there. I also want to point out that when I set the z sub y to equal to 0, I get x squared minus 4x 2y minus 3 equals 0. This means that x equals 0, 4, and that y is 3 halves. And we can see that we have covered, when y is 3 halves, we're here. And when x equals 0, we are here and here. And when x equals 4, we are here and here. So we've actually covered all those other ones. So our two systems of equations really jive to one another, so I don't need to explore the other one too much. We have all 5 of our potentials. Now what we need to do is test each one at the second derivative level. So you can see the blue equations at the top right here that I have. I'm going to need to use those so that we can deal with, once again, that. And let's start with, at the point 2 comma 3 halves. And let me just do this. F sub x, I'm going to recopy these down. It is 2 times y squared minus 3y. F sub y is 2 times x squared minus 4x. I'm just copying from above. And x sub xy is 2x minus 4, 2y minus 3. Okay. So if we explore this at our critical value, we're going to get 2 times 3 halves squared minus 3 times 3 halves. Let's plug that in and see what we get. So 3 divided by 2 squared minus, that becomes 9 divided by 2, then times 2. And we're getting negative 9 halves. F sub y of 2 3 halves is 2 times, this is now x, so this is 2 squared minus 4 times 2. So that's 4 minus 8, that's negative 4 times 2 is negative 8. And f sub xy at 2 3 halves is 2 times 2 minus 4. 2 times 3 halves minus 3 is actually 0 times 0, so we just get 0 there. The first one, 2 times 2 is 4, 4 minus 4 is 0. And then the 2's reduce out, actually we get 3 minus 3. It actually doesn't matter. Once we get 0 times, who cares? The whole thing's 0. The point is our d here, specifically at 2 3/2, is negative 9/2 times negative 8 minus 0 squared, which is a positive, let's see, that becomes 4 times 9, 36. Which is positive, which means we have a local max at the point 2 3/2. Yay. So there's our local max. We have 4 other points we have to explore. Let's see what we get. So at the point 0, 0, f sub xx at 0, 0 is 2 times 0 squared minus 3 times 0 is 0. F sub yy at 0, 0 is 2 times 0 squared minus 4 times 0, which is 0. And f sub xy at 0, 0, we get 2 times 0 minus 4, 2 times 0 minus 3, that's negative 4 times negative 3, which is a positive 12. So we get that d is negative 144, which is obviously negative. This means there's a saddle point at the point 0, 0. And I should have highlighted this a little bit better. Thanks. All right, so next up we have the point 4, 0. And f sub yy at 4, 0 is 2 times 4 squared minus 4 times 4. And ironically, 4 squared minus 4 times 4 is just 0 again, so the whole thing goes to 0. And f sub xy at 4, 0 is, so this is going to be 2 times 4 minus 4 times 2 times 0 minus 3. So that's going to give us, let's see, 8 minus 4 is positive 4 times negative 3 is negative 12, but it won't matter because d at 4, 0 is 0 times 0 minus negative 12 squared. Now be careful. We don't have a minus minus situation like you might think. This actually becomes 0 minus 144, which is negative 144, which is less than 0, which means we have a saddle point again at the point 4, 0. So this one isn't particularly difficult. There's just really long. We have 2 more points to explore. We have 0, 3, and then 4, 3. So at the point 0, 3, we have f sub xx at 0, 3, which is 2 times 3 squared minus 3 times 3, which that gives me 9 minus 9. Again, we get 0. We get 2 times 0 squared minus 4 times 0, which again is 0. And here we have 2 times 0 minus 4, and then 2 times 3 minus 3, which gives us negative 4 times 6 minus 3 is 3, again, negative 12. Oops, so negative 4 times 3, yeah, so negative 12. So D at 0, 3 is 0 times 0 minus negative 12 squared. Again, be careful with the double negative. There is no double negative. This whole thing becomes negative 144, which is less than 0, which means there's a saddle point at the point 0, 3. And our last one is at the point 4, 3. So we have 2 times 3 squared minus 3 times 3. Once again, that very nicely gives us 0. F sub yy at 4, 3 gives us 2 times 4 squared minus 4 times 4, which once again gives us 0, which is, again, very nice. So now we're going to have 2 times 4 minus 4 times 2 times 3 minus 3. So that gives us 8 minus 4, which is 4. 6 minus 3 is 3. That once again is 12. So D at 4, 3 is 0 times 0 minus 12 squared, which once again is negative 144. Whew. That is a long problem. But again, not particularly difficult. All right, next up, we have a revenue problem. I'm going to go to a new page here. And I want to go to here. So we're at number 5 here with our revenue issue. And I'm going to actually write it into here. There's plenty of space here. So R sub x with respect to x only is going to be 140. 70y is gone. Minus 4x squared becomes 8x. 3y squared is 0. Derivative of xy with respect to x is just y. So 140 minus 8x minus y. And r sub y, again, 140x is gone. This is going to give me 70. Minus 4x squared is gone. Minus 6y. Derivative of xy with respect to y is just minus x. And we're going to set each of these equal to 0. Which means this becomes y equals 140 minus 8x. And this becomes, actually, we don't need to do that. I'm just going to dump it in. So I'm going to put that into, so let's color code this a little. So I'm going to put that into there. And then hopefully we can solve this system. So we get 70 minus 6 times 140 minus 8x minus x equals 0. 6 times 140. So this becomes 70 minus 840 plus 48x minus x equals 0. this becomes 47x. When I add the 770 to the other side, I get positive 770. So there's my x coordinate. To get the y coordinate, I'm going to go back up to the highlighted blue up there, plug in my x. Let's see what we get. 140 minus 8 times 770 divided by 47. And we're getting 420 over 47 is my y coordinate for my critical value. So let's just write this in. So this is 770 over 47. And this is 420 over 47. And it can be written as a point. However we want to write it, it's all the same answer, no problem. And that brings us to our Lagrange multipliers. I would like to use a separate sheet of paper for this one. So I'm going to go, I probably could make it fit. You know what, I'm going to try to make it fit. So let's do part A. Part A is going to be, first of all, let's write out what we have. We have our constraint function. We have okay, so let's start here. Lagrange multipliers implies that del f is equal to some constant times del g. The gradient of f, gradient of g, nickname is del. And just to be clear, del f is f sub x, comma, f sub y, and del g is g sub x, g sub y. So our first one in our brackets here for our del f is the derivative of f with respect to x first. That's going to be 2x plus 2y. And then the minus 4y squared is gone. And the second part of that is going to be the derivative of the same function, but with respect to y. So that's going to be 2x minus 8y. Now, the function g of x, y, I need to explain. That's when my constraint is equal to 0. So that's going to be 8x plus 12y plus 152. And they've already given that to us. Let me highlight that real quick. That's where that comes from. They just added the 52 to the other side. And so if we do del g, that's the derivative of g with respect to x first. That's just going to be 8. And with respect to y, that's going to be 12. And so there is part A. However, part B is going to be a little bit more complicated. This is our del f is equal to some constant lambda times del g, which means that 2x plus 2y is going to equal 8 times lambda, and 2x minus 8y is going to equal 12 times lambda. And what I'm going to do, and by the way, I have two equations with 3 unknowns, meaning the x, y, and lambda. However, I do have a constraint as well. Which I will use here. So here's my 3 equations with my 3 unknowns. This top one, I'm going to divide through by 8, which gives me that lambda is 1/4 x plus 1/4 y. And I'm now going to plug all of that into there. So I'm going to come over here. 2x minus 8y equals 12 times and multiplying through by the 12, I get 2x minus 8y equals 3x plus 3y. And I'm now going to solve for x in terms of y. So I'm going to subtract, let me show you, so minus 2x, and I'm going to add 8y. Yeah, no, I'm not. I'm going to subtract a 3y, which is going to give me 3x minus 2x is just x. Negative 8y minus 3y is negative 11y. All right, I'm now going to take that and I'm going to solve my system. So let's take our 8x, let me highlight what I'm doing here. So let's take that there. This is my constraint. And I'm now going to plug in for x. For x is going to be here. So 8 times negative 11y plus 12y is negative 152. That's going to be, let's see, negative 76y equals negative 152. And if this is a lovely textbook problem, 152 divided by 76. Look at that, so nice and pretty. Y equals 2. I'm going to come back up here. X equals negative 11 times 2 is negative 22. So here is my critical point. Oops, it's the wrong color. There we are. So that goes right here. And it says now find the maximum value given the constraint. So what this is saying is, this is part C, is we're going to find f of, this is our original function. Let me rewrite it. Our original function, x squared plus 2xy minus 4y squared. And we are now going to evaluate this at negative 22, 2. Meaning when x equals negative 22 and y equals 2, what do we get? And putting all that into my calculator, let's see what we get. So 22 squared, I know it's negative 22, but negative 22 positive 22 squared is still a plus positive 22. So that's going to be minus 4 times 22, 4 times 22. I just did the 2 times 2 to get the 4, and then times the 22. And then minus, so 2 squared is 4, 4 times 4 is 16, so minus 16. I'm getting 380 is my optimization. And there are all of my answers as we are looking at that. And that, my friends, is business calculus. It's been a pleasure. I hope this all helped. Good luck on your finals.